Hello, what's up YouTube? This is Mainak and today we'll do a professional video tutorial on Etabs. So I'm going to giving out some of the uh, build order of the design considerations which professional structural engineers make while designing. So we're going to take all the study materials, by the way, will be available and in the downloads, so you can check that out. So there will be a PDF of a building. We'll have the plan and the elevation in the PDF, so that you can model the building properly. And then I'll also attach the design considerations which we have taken. So in detail you will get to learn the design procedure, and if you want to add anything or if you think anything is wrong, then feel free to write in the comments, as we believe, as told Pikachu, you know we learn together. So that's it. And let's go. So we'll open Etabs first of all, and the first thing which we are going to do in Etabs is make the grids here. Okay, and before that, let's observe the structure, because when a structural engineer designs a building, first the job is to observe the structure. So here I can see the number of grids which are done by the architect. Here these four grids here, and we have one, two, three, four, uh, one, six grids here. So this is basically a hotel or a lodge kind of a building here, and the elevation of the building is here. So the design considerations, let's go through the design considerations of the building here. So this is project number 13, which I have done in YouTube. So building type is G+1 with RCC, steel truss on top, and floor to floor height is 3 meters, plinth height is 0.45 meters, and from the soil test report we got that the foundation depth is 1.5 meter, and so total column below the plinth will be 1.5 plus 0.45, that is plinth height plus foundation depth 1.95. SBC is 130 kN per meter square at 1.5 meter. Building will be designed by Etabs software. So this is an Etabs tutorial. And grade of concrete, as per the tender documents, we have to take M25 and FE500. And initial section considerations. Now, initial section considerations, you have to take with your experience, and it comes with experience. If you don't have experience, we can go to 15 to 250 for columns and 15 to 300 for beams, and you can just get around with your way with that. Okay, so we want to start with this initial design considerations, and then we move forward. Okay, so slab thickness we're going to consider here 150 mm, and beam we're going to consider 300 into 450. Grids in x direction. So I have just added the cumulative sum here. I'll just give one example here, just to let you understand, because anyway you can practice along with me. The main focus of this video tutorials is to you that so that you can practice along with me, not just for watching, so that you can pause the video, practice along with me. Okay, so and if you appreciate my effort, just drop a like, or drop a comment, just to show that you have reached a particular point. Okay, so yeah, so 3.6, 2.7, and 3.6. So these are the grids here. So first grid here, let me just close this, or open this later. Okay, so yeah, so the first grid is 3.0, and then it is 3.6, and then it is the next grid, it is 3.6 plus 2.7. Let me just show you practically with calculator. So it is next grid will calculate 3.6 plus 2.7, it is 6.3. So we have written here 6.3. So similarly there are four number of grids here, and in Etabs we calculate the grids in y direction from bottom. So this is 0, this is 2.2, that is B, and when you go to C, then it is 2.2 plus 2.6, sorry, 2 plus 2.6, which will be 4.6. So that's why you'll find here 4. Sorry, it will be 4.6, right? Just made a mistake, I think, in the adding. Okay, let me just correct that. Okay, so it's well that I made a mistake, because just to show you, it's all planned. Okay, so 2 and then 2.6, 2 plus 2.6 is 4.6 here, so it will be written as 4.6, and then that is 4.6 plus 1.4, just close this one, leave one. 4.6 plus 1.4 is equals to 6. So then it is 6, and 6 plus 2.8 is 8.8, and 8.8 plus 8.8 plus 1.995 is equals to 10.795. So we'll do this 10.795. Let us check the final dimension. So it is 10.715, so we're good here, and this is also 9.9 in the x direction. So in the x direction also 9.9. so this grids are okay, so we'll do this. So now let's open Etabs, because let's finish the doing the grids, and then we'll go to the remaining considerations to make this interesting. So first of all, we'll go and create a new model here in Etabs, and the first thing which you need to do in Etabs is to save the file location. So I've opened the file location in my project 13, and I'll just name this file as 1, and as I clicked on open, not open, I have to click on save new model first, and then we'll save this. Okay, file new model, and then we'll just do metric SI Indian, and this is steel code and the concrete code, and then click on OK, and then we create the grids. After that we go to save. Okay, so the custom grid spacing will do. Okay, so already we have prepared the grid data, we'll just copy from this. So it is next grid is 3.6. So this is X grid, right? So X grid is in this direction 3.6, and then we have the next grid is 6.3, and then we have here 9.9. okay, and these are the grids, 4 grids, and this we have 6 grids, 1 2 3 4. We need to add more, 5 and 6. Okay, let's go to second grid. It is 2. Okay, 2, then it is 4.6, then it is then we have 6, and then 8.8, 6, and then 8.8, and then last 10.795, 10.795. okay, these are the grids here, 1 2 3 4 5 6, and A B C D. So 6 and 4, so that's the number of grids here. I'll just click on OK, and then we'll do the custom story data. So stories base will be at minus 1.95. Why minus 1.95? We already have decided here. Total column below footing 1.95. Good. And then this we want to keep this at 0, the plinth level. So we want to keep this as height as 1.95. So we keep this height as 1.95, the plinth level becomes 0. So there are several advantages of keeping the plinth level at 0. We'll discuss later, but I prefer to do that. Okay, so and then the next height is 3 and 3, and we don't need the remaining height, as we'll model the steel later. Okay, so this is plinth level, ground floor slab, first floor slab. So you can also rewrite this plinth level and GF slab, and you can do this ground floor slab, FF slab. Okay, and then click on OK. Just click on OK. So this is done, and you will observe the model here. Typically in Etabs 2016, and also I think if I'm right 2020 also, this appears in 2 windows. Typically one will be the plan view, one will be 3D view. You can change this later. Okay, by closing and opening elevation windows or other windows if you like. Okay, so this is the grid which is prepared here, and now we need to go to the next step. So we'll define the material properties here, and we'll add new material. So for adding new material, we need to know from the design considerations. So the grade of concrete is M25 and grade of steel is Fe500. So we will add these 2 materials here in the Etabs. So we'll obviously go India, and then we'll go with concrete and M25 concrete. Don't need to change anything because everything is saved. Add new material, this will be just time. We'll add the rebars, and the grade of steel is Fe500, and we'll click on OK. So these are default properties which you have added. Sometimes you forget to click on OK, so that's why I recommend just check whether your properties have been added or not. So after that you can click on OK again to close. Now we're going to add the section properties. So section properties we're going to add as per our assumption which we have made. The column size will be 300 into 400 which we have made, and the plain beam and roof beam will be 300 into 450. So one can argue like we can do the plain beam and roof beam different, but since the giving the 450 height is, since the plinth height is 450, there are no bricks required. 450 will cover that. That's why I've just taken this as 450, but I generally think 400 will also be safe in this condition. Okay, let's go with 450 for now. Okay, so you can add new property, but I'll just add the steel, not the steel, concrete column. We'll edit this and we'll change this. Okay, so if you're adding new property, make sure you just change the this to columns. Okay, but if you are rewriting in this, already the column will be there, so no need to change. That's why I'm just to save time, I'm just doing this. So my column size, our column size will be 300 into 400. This will be our size for the columns, and the material will just change the concrete grade. Width is 300 and depth is 400. Okay, modifiers. So now before going into that, I think we should just focus on the loads here. So okay, briefly we focus. So dead load 875 part 1, self weight, which is automatically calculated by the software, and the wall load of beams we can calculate using the general weight formula. So 20 kilonewton per meter cube is the weight of plaster, and 19 kilonewton per meter cube is the weight of red bricks as per 875 part 1. And so I've taken the maximum one just to give an approximate value on the higher side, and this height is the height of the wall. So if we take the height as a 2 point beam as 0.45, so 3 minus 0.45, it comes as 2.55. that's why I've taken this, and 0.25 is the 10-inch wall, the external wall thickness. So this gives us the load of the UDL in kilonewton per meter. So it comes around 12.75. I've taken 13. Just to be on the higher side if you decide to just reduce the size of the beam. Okay, floor finish loads are the loads of the tiles, clay tiles, single charge petrified tile, double charge petrified tile. You can see as per the code. Maximum I think is 0.25, 0.3. I have taken 0.5, bit on the higher side. For trusses, we'll consider this later, truss loads, and also for the truss also we'll consider 5 kilonewton per meter square for the roof truss. So there will be the roof truss, and there will be bottom chords of the roof truss. So approximately there will be not much load here. Approximately we'll consider 5 kilonewton per meter square for the roof truss on the first floor slab, not on the ground floor slab. We'll consider just to account for the load which will come on the roof truss. Okay, I think this will be a little bit on the higher side again, but it's no big deal. Okay, so yeah, so this is the dead load, and the live load. This building can be classified as residential. If you just look into 875 part 2, one pick any code, the building classification is given, so it comes under residential. Since this is a hotel or lodge, and the load overall depending on the type of the rooms, because there are different loads for kitchen, different loads for storerooms. In the residential building also we have basically bathroom and rooms here. There is basically, if you just look, there is no kitchen or anything else, so we're going with 2 kilonewton per meter square with overall load which we have decided here. And wind loads will add as per 875 part 3. Basic wind speed, the location is in as per the location you can just decide the wind. So the building is in northeast location and state Tripura, northeast India, Tripura, and the basic wind speed you can calculate as per this code, see as per this code. So by the way, this is the page number, this is the page number which you will download the code, and this is the page number of the PDF, not the actual printed copy. Okay, printed copy might be 1 or 2 pages different depending on the version you use. So terrain category is 1, probability factor 1, K3 factor 1, K4 factor is also 1. I'm not going to the details, just check in this pages all the additional, because I don't want to make this too long. You can check in this pages. Seismic load, my favorite seismic load. Our favorite we should call it, because our viewers are most of my videos are on the seismic load. So seismic load 1893 part 1 2016. Our structure lies in seismic zone 5. By the way, there are other things in the seismic load which I have not added here because Etabs take those automatically. If you want to add, check the in seismic load in detail, check any of my videos on STAAD.Pro, the latest one you can check, and you can find out the important clauses of 1893 in more detail. So seismic zone factor we have to take 0.36, and we take this as per the table number 3 for seismic zone 5, or this is in 0.36. And if you want to know the seismic zone, there is a map in the code 193. You can just check from there, and always use the latest code. The date which I am recording this particular video, this 193 2016 is the latest code. Okay. So, and if this then the response reduction factor. So in zone 5 it is recommended to take SMRF buildings, special moment resisting frame buildings. Okay, so the response reduction factor is 5, and the importance factor is 1 here for all other buildings. Here you can just check read this in detail. I'm not going to do that right now. Damping ratio is taken as 5% as per clause 7.2.4. Vertical effects of earthquake should be considered here because our structure lies in seismic zone 5. So as per clause 6.3.3, the vertical load effects should be considered. And then we have the imposed loads to be considered in the seismic mass. What is the seismic mass? Briefly, very briefly, dead load in full amount and a live load in a in a particular amount. So dead load in full amount and live load if it is less than 3, in which our case our live load is 2 kilonewton per meter square, so it will be 25%. If it was more than 3, then it would be 50%. And if you are adding live load on the roof slab or the terrace slab, then it should not be included in the seismic mass. Then it should not be. It can be omitted from the seismic mass. So that's another clause. So in our case there will be no terrace because there is the above our roof there is a truss, so we can ignore that. And float diaphragms, if we are adding wind load, the float diaphragm should be considered, and the float diaphragms should be considered rigid. And in general buildings, it will mostly 90% cases it becomes rigid, but if it is a special structure that is larger openings and all, then it can be flexible. So, but you have to check then the deformation. After the results you can check. So that's, but in our case it will come as rigid only. And cracked section property, that's why cracked section properties we have to consider moment of inertia 70% for columns and 35% of beams, 35% for beams. So this whole idea is to make strong columns and weak beams. So it takes me back to my just to check my design consideration, which I have taken 300 into 400. The size of the beam is, if you just look into the cross sectional area, size of the beam is more, but I'm just having second thoughts if I can reduce this size of the beam or here. Okay, let's do here 400 only. Let's do 400. Okay, what else? Or if our slab is 150, then let's do 400. If we do 400 here, then this will be 2.6, and then the calculator 20 into 2.6 into 0.25 is 13. So I've taken the higher side, so that's okay, good. Let's go 0.4. Okay, so where were we? So vertical, so yeah, we were on the crack section properties. So method of structural analysis will go with both static and dynamic. Seismic zone 5 you have to do, if your building is above seismic zone 2, then you have to consider the response spectrum, dynamic method. And in the dynamic method there are time history analysis, response spectrum. We are going with response spectrum method, which is the most preferred method here. And then you have the model mass and number of modes check. This will be done after the analysis. That our number of modes should be 90% of the model masses should be 90% of, sorry, I have to read the full thing. No, I cannot skip. The number of modes NM to be used in the analysis for the earthquake shaking. Along considered direction should be such that the sum total of the model masses of these three modes is at least 90% of the total seismic mass. So we have to check this after the analysis complete. And as per another clause, the first three modes should contribute at least 65% of the mass participation factor. Number of modes you can consider by default 3 into number of floors. This is for a thumb rule. And if it doesn't match, then you can increase the number of modes later. It doesn't satisfy this criteria. So this is not a big deal, but it is checked by every vetting authority. Okay. So after that we go to property modifier and moment of inertia. Since this is our column, so we'll do this is 0.7. So this is done as per this 0.7 70% as per 6.4.3.1 both axis 0.7, and then okay. Reinforcement we'll do this as this 500 and then click on OK. We'll click on OK with this, and for the beam also we'll just modify the property here. B 300 into 400 we've decided, right? 400, and this will be M25, and property modifiers, just moment of inertia point, you can see property modifiers for beams 0.35, okay. 35, and here also 0.35. Click on OK. Reinforcement is this, okay, and this width is 300 and depth is 400, okay. We have changed this rebar material, okay. Then click on OK, and I always prefer to second check the sections, because sometimes you miss to click on OK and this doesn't get saved. Okay, so this is saved. So we have defined the frame sections. So after the frame section definitions, so next we'll go to define, and we'll go to load patterns here. Dead load and live load is added, so I'll add the other dead load, and this self weight multiplier will not be there here, and add this new dead load here, and then we'll also go with all the other dead load floor finish and load onto the wall will be added here, and then we'll add the seismic load SLX, and this will be seismic. Select the code. Latest code is not here in this version. Always select the latest code, okay. To go with this, if we're using higher version, then 2016 will be available, so add that version SLX and SLY. So in Etabs, in this for the static load, there is no option of adding the vertical earthquake effects in this Etabs 2016. This makes sense because in 2002 code there is no vertical load, okay. So obviously makes sense. So I cannot add SLZ here, okay. So WL wind load I'll add here. So what we'll do, wind load will add just little bit of thumb rule on the hair side. So I'll add a factor of 1 on all the leeward side and a factor of 1 on all the windward side. You can add it if you want to add accurately. You can go as per the code, okay. So you can check out my document, which I'll probably give in the description. You can check it out. But if you follow this method, this you'll be on the higher side, will be on building will be safe, design will be safe. So no worries. So Indian, not this one, not this one. This one. Okay. Let's edit this. Since this is X, Y is not required, and yeah, 0.36 we already have taken this as per how we are doing the in the design considerations. Already this is taken into account. I think this is the first point, like yeah, 0.36 seismic zone. Since there are for seismic zone 5. And soil type, this is not given here. I think this table is also present. Soil type, this as per the soil test report you have to indicate that. So soil type 1 is for soft soil, and 2 is for medium soil, and 3 is for hard soil. So we're taking the medium soil here, and okay, wait, let me just add this also in the design consideration. So I've added. So you find that okay, so I've just told the order wrong. So 1 is for hard soil, 2 is for medium soil, and 3 is for soft soil. So if depending upon the soil test report and depending on the N value, you can just take the type of soil also. So it generally is indicated in your soil test report, the type of soil, so you have to refer to that. So in our case, our soil is medium soil, okay. So let's go here, soil type 2, and this is bottom story is always the plinth level here for seismic and wind load. and eccentricity is 5%. We already have considered this. Response duration factor 5%, already considered this in the design considerations. And time period, if you want to calculate, you can do that. You can check out my detailed video on the seismic load. I've just told the clauses there, and just click on OK here, and here we'll modify the lateral load. This is in Y direction, so again we'll go PL, and the remaining things will remain the same, and click on OK. Wind load, and modify the wind load. Basic wind speed 55. Again, this will be everything as per the our considerations. Bottom story will be plinth level. Exposure from shell objects, we'll give a shell, and then we'll apply the wind loads. Similarly, we'll do changes to this as well. Modify lateral load 55. Terrain category 1. Exposure from shell objects, PL. Okay, done. And again I'll check load patterns again, just to check everything is okay. So everything is done. So next step is to define the seismic mass. So we'll go to the seismic mass definition. We'll go to define, and then you have mass source, and we'll just added this mass source here. First of all, additional mass element self mass will include, and the specified load patterns will include dead load, other dead load, and then for the live load we'll add 25%. So already we've discussed this in the design consideration. For new people, I'm just showing this again. If you cannot find this, no problem. Okay, starting takes, yeah, this is the table number 10. Just check it out. Okay, so we'll click on OK and click on OK. Okay, so define the seismic. So now we'll define the response spectrum function. Define, and go to the functions, and we'll define the response spectrum function here. So we'll delete the function here first of all, and we'll add new function. Not as per ASC, we are going with Indian codes, so you have to select the Indian code here, and then click on add new function here. Function 1, obviously. This is the seismic zone factor, soil type. This already we've discussed. Just click on OK, and then click on OK. So response spectrum function you have added. So now go to define once again, and then we'll go to define model cases, and we'll just add in this to add the response spectrum load, and we'll call this RS for the response spectrum, and we'll go with grids here, and then we'll go with here we'll add here 3 load patterns, and this will do acceleration. Since our load is in 3 directions, so not link acceleration, so it will be in 3 directions. Accelerations will add number of modes, as I told. This is a 2-story building, so 2 into 3 6. If you do it, then it's enough. By default it's 12, so let it be that way. If our criteria doesn't satisfy, then we have to increase this, but in this building we don't have to increase this, I believe. Okay, so next we'll go to define, and we'll go to our load patterns here. Sorry, not load patterns. We'll go to define and the load cases here, and then we'll add a new load case here, and we'll add the response spectrum loads in the 3 directions. So static loads, earthquake loads already added in the 2 directions, and the response spectrum load we need to add in 3 directions. So we'll do here RSX here, and then we'll do this response spectrum, and we'll add the acceleration here in the first U1, and then this is a scale factor. That is a lot of debate around this scale factor. Basically your dynamic factor and static factor. Dynamic factor should not be less than the static factor, so that's why the scale factor is there. But for Etabs, officially in the CSI website, that is the manufacturer of CSI, the manufacturer of Etabs, that is computers and structures, so they have already given the the scale factor, so we can refer to that. This is the official source on the CSI website. This is for the American codes or the other codes, and this is for the Indian codes. So we're going to the Indian codes. So what it tells is it should be IG, scale factor should be I into G by 2R. So we already know what is I is importance factor, G is acceleration due to gravity, which is 9.8 meter per second square. You know that already. 2 is 2, and R is response reduction factor, which is 5 in our building. So you can just calculate this. Okay, I is 1 into, why I'm doing 1 into 9.81 divided by 2 into 5, that is 10, and it will come as 0.981. So we can take 0.98 as our scale factor. So just we'll take 0.98 as a scale factor. So we always go with the official source when you find different things for different so we go with 0.98, and in our case, if we check that the dynamic response spectrum is less than the static response spectrum, then we multiply an additional amount to this scale factor. But basically, for in the starting, your scale factor should be this, as per this Ig by what is the formula here, Ig by 2R for the Indian code. Okay, so if you're following the American code, then you should go with this. I think this is Ig by R into this one. So okay, so yeah, so having said that, just click on OK, and we'll add a new load case here, and this will be RSY, response spectrum, and acceleration U2 0.8. By the way, you can change the mathematical method to solve this also, but keep this as default. If there is depending on the results, you need to change, but for starting, for beginners, keep this as default. In the vertical directions, we are adding the load. Okay, click on OK, and we are set here. We think we have done a lot of progress. We need to save the file, so just that this file doesn't get lost. So we are saving this file here. Yeah, so the saving is done, and we'll continue with the important thing, which is the modeling. So for the modeling, I'll just just look into the document which I provided, and we can zoom in into one of them. Let's model only the frame. There is no significant amount of secondary beams. I think one secondary beam you can give here, or you can add that later, or you can even skip that if you choose to. Let's add the secondary beams here. So here, let's look into the grids. We have columns in each grid, so there is assigning columns should be simple here. Okay, so let's do that. So here we'll take the column here, quick draw columns, and we'll just take the column size here, 300 into 400 C. Yeah, not each grid, I think. Yeah, because yeah, I think the columns are here. I want to change the orientation of the columns angle degree to change this to 90 degree. Okay, yeah, I want the columns like this and like this. Okay, and yes, actually the columns are on every grid here. Let me just check here. Yes, on each and every grid there are columns, so we have inserted the columns here, and the story below also. Let's okay, we have to add from the plinth level also. We'll do the same. So columns are assigned now in all the levels here. We'll check in 3D diagram, the columns are assigned. So let's go the plinth level in 0, and let's go for the beams. So the plinth beams, here we have quick draw beams or columns. Indeed, this option, we'll just do 300 into 400 here, and the plinth beams will go like this, and like this. Yes, I think this is the beam action. Yes, this is the beam action actually. So yes, so we can copy this beams here, or you could select using the select option also. Let's continue since we started only. Select this beams, and Control plus R to replicate. This sort option you can also go to edit and then do this. So we'll go story, and we'll replicate in ground floor slab and first floor slab. This is the plinth level, right? Just hover over to apply. Just you can click on the 3D view and hover over to apply just to check, and click on OK and OK. I think it is got only selected in this particular level. One level is left. Okay, so I will go to select and get previous selection, and you go to Ctrl+R and replicate. Go to story, ground floor slab. Yeah, we had missed this earlier. Apply and OK. Okay, so see the model is done here. Now we'll assign the supports here. Fixed supports will be assigned. Select this, assign joint and restraints, fixed support, apply and OK. So the supports are now fixed. Now I'll go to the plinth level and we'll define the wall loads. So what are the wall loads which we have decided here? Let's go to the dead load. The earthquake load part is finished, so dead load and live load 30. So we'll select all the beams, in this level, and we'll assign frame loads distributed load of 13. Click on. Now we'll just do this in the other dead. Click on apply and click on OK. Okay, in the next floor also we'll go to the next floor. In this floor also we'll apply the same load. There's a ground floor slab. Assign frame loads distributed 13, apply and OK, and then we'll go to the next floor. So in the next floor we are considering 5 kilonewton per meter square for the as a load for the nominal load for the truss. So these are basically, these beams are to support the truss. There will be no roof slab, but personally I think then they decide to just change the design at some point and give slab, RCDC slab, then it will also be able to take the load. We'll design in such a way. Okay, assign frame loads distributed, and we'll add a load of 5. Apply and OK. So this is done, and we have to add the slabs here. So in this level there will be no slab. I will go to the plinth level, there will be no slab, and this level there will be a slab, so we'll add the slab. So we'll define section properties, slab sections. We'll just edit the slab 1. We'll do slab 150 mm. Change the property here, M25. Shell thin is okay, 150, and modifiers is okay. You don't need to. Combinational side data is okay. Yeah, remaining things are okay here. By the way, slab is not designed in Etabs, only for providing the loads. Okay, so we go here, I think for rectangular slabs. So I have to just check the staircase location in the plan. So the staircase location is this. Apart from this, every position there will be a slab. I think in this position also, if we avoid the slab, then it's good. No, in this position we have to give the slab, and only in this particular, these two grids, the slab will not be present. Okay, so quick draw slabs, I think I can use that option, slab 150 mm. So you avoid these two, and in the remaining parts you can give this slabs. Done. So I think we can replicate this. No need to replicate, because the next floor there will be a roof truss, so there will be no replication required. So basically we can select all these slabs here. Okay, well, or else you can also do using this option, select properties, slab sections, slab 150, select like this. You can select Okay, so and you can assign shell loads uniform, and this will come under other dead loads. This will be flow finish load 0.5. Click on apply, and after that go to select, go to get previous selection, and then we'll apply the live load here, live load of 2. Click on apply, and then click on OK. And the diaphragm is actually present only in this particular level, but let's apply on all the 3 levels if required. But slab is only present in diaphragm is a member which transmits the near vertical or nearly vertical members to the horizontal or nearly horizontal members to the vertical members. So in this case, the diaphragm is only present in this particular floor. So let's define on this particular floor. And why bother? The diaphragms, modify diaphragm. This is rigid, so it's okay. And we'll select this, and after that we'll assign joint and diaphragms D1, apply, and OK. So diaphragms have been applied in here. Okay, you can there is no particular rule that if you don't need to apply diaphragms there, but generally you don't need to do that. Okay, so if you want to add diaphragms in other 2 floors as well, we'll go to define, and we'll go to diaphragms, and we'll add 2 more diaphragms. Add new diaphragm D2 and add new diaphragm D3. So we'll in the plinth level, let's go to the plinth level 0. Plinth level, we'll select this, we'll assign joint, assign joint diaphragms. Oh, I haven't saved that. Define diaphragms, add new diaphragm, okay, add new diaphragm, okay, just click on OK. This is selected, right? Assign joint diaphragms D2 in the plinth level, and in the uppermost floor, terrace floor, select we want to select, okay, assign joint diaphragms D3, apply, and OK. Okay, so 3 diaphragms we have applied, but basically in practical diaphragm will be only on the 1 floor. Okay, so diaphragms we have applied, live load we have applied, dead load we have applied, seismic load will be done automatically. We have defined on the parameters, so we need only one thing. So let's add this, what you call, quick draw floor wall plan, and this will be properties will go none, just for the wind load definition. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Done. Okay, select, right click, okay, just to select this, not right click, select this, no need to press Ctrl like AutoCAD, it's not similar to AutoCAD. Select this, and you go to assign shell loads, wind pressure coefficient. First we'll apply on the windward load 1, and then go to select, get previous selection, then we apply on the leeward side 1, or I think we'll add on the leeward side Yeah, leeward side 1 is okay. Leeward side 1, windward side 1. Okay, leeward side 1 and windward side -1. Okay, just let me just show this. Display, load assigns, shell loads. Let's go 1. So just for checking if this is applied or not. 1, windward side 1. Leeward side is applied or not? Yeah, 1. Okay, this is fine. And then we'll go to define load combination. By the way, there are default load combination as per Seismic code which you need to add, but we have to add this manually in Etabs. So just we're going to go with this default combos, concrete frame design. Okay, and click on analyze here. So analysis is complete here. So after the analysis is complete, we go to this concrete and start design check. Okay, so now we are also going to design the give the detailing results. Okay, first of all I'm going to select this, right click and no, just select this. I'm going to just ignore the slab parts. Let me just close this for now. Okay, right click and hide selected objects. Okay, so now let's decide for the columns first. So first of all we need to check here, right click do this and check if any all members are passed. So all members are passed, so our initial design assumptions are correct. Now we need to decide the what is the reinforcement in the column. So for that you need the column areas here. Okay, so bar radius, so pi by 4 into d square. So suppose for 16 mm bars, pi by 4 into d square is pi by 4 into 16 square, which comes as 20. So like this we need to do this. So column, what is the required AST required? What is the AST required? So we go with the maximum value here. We have a 960 here, so to check whether everything anything is above the 960. Obviously if you check the bottom bars, then it should be okay, because the maximum moment will be in the bottom. So everything is coming as 960. So let's go here in this, write this in this bar area 960. So if we provide, suppose let's say 60 mm bars, 4 bars of 16 mm, okay, is equals to 4 into 16, then it comes as 800. So this is not sufficient. So what if we provide 4 bars of 16 mm and 4 bars of 12 mm? Okay, so just write here AST required, this is AST provided. Okay, provided. So is equals to 4 bars of 16 mm, 4 into this 200 plus 4 bars of 12 mm, then its coming is 1256, which is much more than this, and we know that in the size 300 to 400 this is accommodable. We can accommodate this 8 bars of it. So provide 4 16 plus, in just 2t here, not try 5 plus 4 12 t. This will be our rebar in the columns. And in the beams, yeah, size also I can just add a column here, insert column. Yeah, I can just write here 300 cross 400. Okay, now for the beams, let's do this. For the beams, beam size is also, everything is coming as pass. So beam both. So let's do plain first, plain beams. I think all the beams will come same, but let's see. So for the plain beams checking, I think the plan view will be better. PL, apply. Okay, so plan view is better, you can see. So in top and bottom, let's provide the same rebar. So both in the top and the bottom, let's maximize it. 305 here. By the way, if you for large structures, you have to do this everything individually, but since this is small, we can easily grasp this. 305, 305. So 305 is the maximum which I see. Okay, let's go 305 here. Let's take 305. Let's go 350. In fact, 350. So if we provide in this is a beam, right? 300. So maximum bars you can provide in the top or in the bottom is 3 in one layer if you want to provide. So 350. If you want to do, then you provide 3 bars of 16 mm. Will it be sufficient? Is equals to 3 into this. Then it will be sufficient. So we'll provide 316T at top and bottom. So we'll provide this in top and bottom. So we have our column design and our beam design. And for the slab design, you can use Excel sheet, and for the footing design also we can use Excel sheet. Okay. So but I think the video will be too long. So you can use any Excel sheet here which is available. Many people have made Excel sheets which are paid. You can buy them for they're selling it for a very noble amount. You should support them. I have also purchased some Excel sheet for them, but so I recommend you purchase that. Or if you can do manually, design that do the design manually using the loads which I'll show you. Okay, so let me just show you a display, show tables, and then you have the analysis results, and you have the results and reactions, and you just find out the joint reactions. Okay, in this joint reactions, this you can see everything is the base. So just copy this. I'll just show you the procedure of doing this, doing the foundation design. If you want to do this foundation design using Excel, so project 13, and this will be the foundation design. Oh, this comes as F. Okay, just save the file. Okay, so we don't need this, we don't need this, we don't need this, and we don't need this as well. Okay, so now we basically, when you go open any book, we have the force in one, vertical force, and you have moment in 2. So remaining things we don't require. So we don't require this, we don't require this, and we don't require this last one. Right click, delete. So this is P, or this is MX, and this is MY. So these are the loads here, and you can use Excel to calculate the maximum amount of load in P. So just before I will show you the example, equals to max. I'll just give a number here, close this, and I'll see what is the maximum number cell which is going. This is going 1682. So I'll just change this to G 1682, and is equals to main also, because the magnitude doesn't matter here, just the value, the direction doesn't matter here, only the value matters. I'll just copy this. Oh, what did I do? Just copy this and paste this here, and instead of this max, I just type here min, and I'll drag this values. So this is the P, and this is the MX, and this is the MY. So using this value, and the SBC is 1.130 kilonewton per meter square at 1.5 meter depth. So using any Excel sheet you can design, or you can design manually using hand as well. So these are the things you can design. So foundation design you can do according to this. So my goal was to, just if you want to design a building, to take you to the through the entire steps, not just show the analysis, not just show the shear force, bending moment and all. You are a structural designer, you need to design a building, give the final drawings, make it yourself or give it to a draft person, but you need to have the final results ready. So that's how you get the final results ready. And if you want I've shown we have seen the beam design, we've shown the column design, and we've shown the procedure to go for the foundation design. And for this slab design as well, you can just check the spans of the slab, and you can design using any Excel sheet which is available. I recommend you get a paid Excel sheet, superior Excel sheet, or you can do using manual analysis calculations as well. So that's all for today. Thanks for watching the video. See you. Bye bye.